Here's another example of using integration by parts to solve this integral. This one's a little bit unusual. Let's find the integral of sine of 4x times e to the x dx. Again, we have our integrand as a product of two totally separate functions that are unrelated. So u substitution is not going to work, but integration by parts probably will. And again, let's just write down our formula so that we remember it. The integral of u dv, the thing we start with, is equal to u times v minus the integral of v du. What should we choose for our u and our dv here? We really could choose either of these functions for the u or for the dv. Neither one gets simpler or more complicated when you take the derivative or the antiderivative. The only little complication here is that 4x inside the sign, but that will just give us a coefficient, a constant multiple showing up, and that's never a problem when we're doing integrals. We really could choose either one. Just for convenience, I think I'll set my u to be sine of 4x and my dv to be everything else, e to the x dx. As always, we'll want to differentiate the u, or du. We'll have to use the chain rule here, since 4x is a function that's being plugged into or composed with the sine function. So the derivative of sine is cosine of 4x times 4. And we'll find our v. We'll take the antiderivative of e to the x, that is e to the x. Put these all together, our original integral equals u times v, that is sine of 4x e to the x, minus the integral of v du. So we'll take the integral of v du, that is going to be e to the x times cosine of 4x times 4, which I'll put on the outside. And guess what? I forgot to put my dx in here. Here is our dx. Well, now we need to solve this integral. But guess what? It's not any simpler than the previous one. In a way, it's kind of the same. You have a cosine instead of a sine, but otherwise, you have the same structure as the previous integral. Nevertheless, the only tool that we seem to have available to us is integration by parts. Let's try it again and see if we can get anywhere from that. Let's pick our u and our dv, as always. Now, again, we could choose to use the e to the x or the cosine 4x as either our u or our v. We really could have made either choice in the beginning. But if you try and make the u e to the x now, you'll find yourself back in this exact same position you started. Let's keep using the trig function for the u. So let's have u be cosine of 4x. And our dv will be e to the x dx. As long as you follow the same pattern that you followed the first time, that's usually a better plan. Okay, so our derivative, du, well, the derivative of cosine of something is negative sine of that thing, sine of 4x. But we still have to multiply by the derivative of 4x. We're using the chain rule again. That's going to be 4 times dx. And we will take our dv and we'll find the antiderivative to get v. V is, again, e to the x. So we can put this all together. Our whole expression is equal to, again, copy down the stuff you already have here, sine of 4x times e to the x minus 4 times whatever this integral is equal to. We are replacing that one integral with this uv minus the integral of v du. So it's negative 4 times that whole thing. Give yourself some brackets here. Our new u and v are cosine of 4x times e to the x minus the integral of v du. So that is going to be v is e to the x. Our du is negative 4 sine of 4x dx. Okay, let's try to clean this up a little bit. As I've said, it's a good idea to simplify as much as possible at every stage. That means getting rid of as many parentheses as you can, consolidating any coefficients or constant multiples that you have so that you don't have to deal with these negative signs upon negative signs upon negative signs and extra parentheses that are making everything really hard to follow. Let's clean it all up. So this equals the sine of 4x e to the x minus 4. I'm going to multiply that negative 4 times both of the terms that are inside these brackets. So negative 4 cosine of 4x e to the x. Now for the next part, let's look at all of the coefficients that we have. We have this negative 4 in front of the brackets. We also have this negative in front of the integral. And we have this negative 4 that's being multiplied by the rest of the integrand. So let's combine those together. That's 3 negatives being multiplied. That's a negative. And we have a 4 times 4, that's 16, times the integral of sine of 4x e to the x dx. I just swapped the order of that sine and that exponential function because we've been putting our trig functions before our e to the x's all the way through. So I swapped the order, that's all. Well, we still need to be able to solve this integral. Until we can write this as an expression that has no integrals in it, we're not done. But here's the problem. This integral right here is exactly the same as the integral we started with. If we knew how to solve this integral, we would have known how to solve this integral to begin with. We wouldn't be in this situation now. We have what's called a cyclic integration by parts. We did integration by parts, and that gave us a new, more complicated expression that involves an integral that's the same one we started with. So what do? Well, let's turn this problem into a solution. This is actually a good thing. Let's give this whole integral expression that we started with a name. Let's call it maybe a. Well, that means that I can cross out this integral that's showing up in the middle of my last line and call that a as well. In fact, I can write an equation. A equals the sine of 4x e to the x minus 4 cosine of 4x e to the x minus 16a. What we're trying to solve is a. We want to know what a equals, because we want to know what that integral in black equals. If we can write a equals this, then we'll be done. Well, we have an equation now that we can solve for a. So let's do it. All we need to do is add 16a to both sides. And a plus 16a is 17a. And that will equal sine of 4x e to the x minus 4 cosine of 4x e to the x plus or minus 0. This part here cancels. So we're almost finished. We just need to divide by 17. So if we divide by 17, we get that a, which is the thing we're solving for, equals 1/17 of sine of 4x e to the x minus 4 cosine 4x e to the x. And we're done. We've actually solved the problem because we figured out the integral that we're looking for, the integral of sine of 4x e to the x dx, equals this expression right here. Anytime you're integrating some function that involves a product of a trig function and an exponential function, you can probably solve it by doing integration by parts, but it will most likely come out a lot like this. It'll be cyclic, and you'll need to do integration by parts twice, and you will end up with the same integral that you started with, but you can replace that with a variable and have an equation to solve. And if you solve that equation, you'll be finished. Now, what have I forgotten here? We are still trying to solve an indefinite integral. So it turns out we still need to add a constant at the end. And I should have done that earlier on, and I forgot. But there we go. Now we have our real solution.